is our example? You want to estimate the mean amount of money a typical customer spends for lunch at Jersey Mike's. You contact an SRS. Okay, SRS, that's why we have to divide our standard deviation by the square root of n. So this is n. N is 30. That showed a mean lunch tab of 8.57. Well, that's our point estimate. That's X bar. It gives us our standard deviation, okay? Standard deviation is 1.06. Construct and interpret a 99% confidence interval for the true mean of the amount spent. Well, this 99% tells us that I need the 99% Z critical value. Well, we just calculated that, and maybe you wrote it on a sticky note to put somewhere, but that is going to be 2.575. I'm going to go through this problem using the formula as well as the calculator. I do not care which one you do on the quiz or midterm. All right, so the formula, X bar, well, we know that is 8.57 plus or minus our Z critical value for the 99% is 2.575. Our standard deviation, 1.06. We're dividing it by the square root of 30 because this is a simple random sample. Next, this part right here to the right of this plus or minus, this is the margin of error. So when I put this into my calculator, I get that the margin of error is 0.498336. Well, how do I actually find the range of values, the lower and the upper bound? Well, the lower bound would be the 8.57 minus 0.498336. And the upper bound would be the point estimate, 8.57 plus 0.498336. When I do this, and then I'm going to round, I get 8.07 and 9.07. I rounded here just because I know that when we are doing dollars and cents, we only go to 2 decimal places. All right, so that is your confidence interval. So we know, or we are 99% certain that the true population mean falls between this interval. I'm going to go over the interpretation in 1 minute. But now let's see, how could I do this on my calculator? Well, it's actually easier than using the formula. The calculator command is going to menu, then statistics, then confidence intervals. We're doing a Z interval, right? Because n is greater than or equal to 30, we need to change the input method from data to stats, and then it's going to ask you for 4 things, and out is going to pop the lower and the upper bound of your confidence interval. So let's go ahead and try this. Sorry that there's such a light. Okay, maybe I'll do it like that. Okay, so I'm going to go to menu, statistics, confidence intervals, Z interval, and then it says, okay, are we using data, raw data that you entered in? No, we're actually using statistics. So I need to change data to stats, press OK. Now it asks me, well, what is sigma? Well, that's my standard deviation. That's 1.06. And then it asks me, well, what is my mean? That's your point estimate. That's 8.57. N is 30. Oop, not 3 point, it's 30. Nope, 30. And then our confidence level also needs to be changed to 0.99. And then I press OK. Well, look right here. It actually gives you your lower and your upper bound of your confidence interval, right? So again, we typed in 1.06 here, 8.57 here, 30. We changed the confidence level to 0.99, and out popped 8.07, just like we got, and then 9.068, which I'm going to round to 9.07. The last thing you need to be able to do after you find these lower and upper bounds is actually interpret the confidence interval. The way I would interpret this is that we are 99% confident that the true population mean of a typical lunch at Jersey Mike's costs between, maybe I should have said costs here, between, okay, well, our lower bound, 8.07, and our upper bound, 9.07. So we are 99% confident that the true population mean falls in this interval. All right. Next, you need to know how to solve for a minimum sample size. All right. There's this formula here, which is actually solving for n for you. So feel free to use this formula. You would be given the confidence level, so you'd be able to find the z critical value. You're given the standard deviation, and you're given the error. Well, where does this formula come from? Well, I just want to show you that our confidence intervals are always x bar plus or minus the margin of error. Well, what is the margin of error in 6.1? It is the z critical value times the standard deviation divided by the square root n. So I'm going to go ahead and set margin of error equal to that. Well, if I were to actually solve for n using algebra, that's where this formula comes from. I actually usually do this. I just actually set my error equal to this. I plug in the z critical value, the standard deviation, and I use algebra to solve. So either way, you can use this formula or this formula. They are the same. They are just rearranged equations. Let's do an example. Okay, example. You want to estimate the true mean distance SBCC students commute to school each day. You want to estimate accurate within. Anytime you see this within, well, whatever follows next is going to be your error or your margin of error. I'm just going to write E. It's your margin of error, which is 0.5. So anytime you see within, whatever follows it will be your margin of error. You want to be 90% confident. Okay, well, from this 90% confident, we can find our z critical value. So we solved this before, but your z critical value is equal to 1.645 if you want to be 90% confident. What's the minimum sample size needed? That's what we're going to be solving for. So we're actually solving for n. Assume the distribution is normal and the standard deviation is 2.4. All right, I'm just going to use this formula. So it's not solved for n for me. I'm just going to use algebra to solve it. The error is 0.5, okay? The z critical value of 90% is 1.645. The standard deviation is 2.4. Divide by the square root of, oh, I don't know what n is. That's what I'm solving for. So now I'm going to use algebra to solve for n. I'm going to first divide both sides by 1.645 to get rid of that 1.645. When I do that, I get 0.303951, and that is equal to 2.4 over the square root of n. Next, I am going to, let's see if I can find a different color pen. I want to get the square root of n out of the denominator, so I'm going to multiply both sides by the square root of n, so those cancel out. Now I'm left with 0.303951 times square root of n equals 2.4. Well, I'm trying to isolate n, so I'm going to divide both sides by 0.303951. 0.303951. I get the square root of n is equal to 7.896, We're almost there, but now I just need to square both sides in order to get n. Looks like the minimum sample size is going to be 62.3468. No, okay? That is not a correct answer. You must always round up to the nearest whole number. You must always round up to the nearest whole number. So this would be a wrong answer. 62 would be a wrong answer. The correct answer is 63 students. Okay, that's the minimum sample size you would need to be 90% confident that your margin of error was within a half of a mile. All right, thank you.